Chapter 11 Magnetic Material. Next topic of chapter number 11 is magnetic moment of electron revolving around the nucleus of an atom. If the negatively charged electron revolve around the nucleus, then what is the magnetic moment? Or we find out magnetic moment in such case when electron are revolving around the nucleus. Suppose we consider the positively charged nucleus and the negatively charged electron revolve around this positively charged nucleus. Suppose this is the R is the radius of that circular orbit. Because the electron is revolving around nucleus, the orbit is circular. Then in such case we find out the magnetic moment of electron. Now consider electron or positively negatively charged electron revolving around positively charged nucleus in circular orbit, and the small r is the radius of that orbit. This orbit acts as a tiny current loop. This orbit of electron acts as a tiny current loop. Then the magnetic dipole moment, will be M is equal to I into A, where I means current, A means area. So equation number 1. Because this orbit acts as a tiny current loop, then we find out the magnetic dipole moment of that current loop or orbit is M is equal to I into A. Now we consider this electron is revolving around this nucleus having constant speed. Suppose V bar. Constant speed P bar, and this electron complete one revolution. Complete one revolution or one rotation, that is to complete a distance, that is circumference of circle. This electron complete one revolution, that is complete one rotation, that is complete the distance. This distance is nothing but circumference of circle, that is 2 pi r. V is the velocity in time, suppose t. Therefore, the speed of electron is given by V is equal to 2 pi r upon t, is the speed of that electron. equation of electric current, I is equal to E upon T, where E means charge, T means time. This is the definition of current. I is equal to E upon T. Also, period T is equal to 2 pi upon omega. Period is equal to 2 pi upon omega. Therefore, I is equal to E upon, using this value, 2 pi upon omega. This is equal to E omega upon 2 pi. To get the current in this tiny loop is I is equal to E omega upon 2 pi. But we know that relation in first chapter, that is rotational dynamics, phi is equal to r omega, where v is linear velocity, r means radius, r omega means angular velocity. This is the relation between linear velocity and angular velocity, or the value of omega is phi upon r. Therefore, using this value, this I is equal to E divided by 2 pi, the value of omega, phi upon r. Or we get I is equal to EV upon 2 pi r. Put this value of I in equation 1. We get M is equal to value of I EV upon 2 pi r into A. But the value of A is pi r square. Then we can write the magnetic dipole moment. Magnetic dipole moment. M is equal to E phi upon 2 pi r into pi r square. Now this gives this r cancel, pi cancel, M is equal to E p r upon. This equation gives the magnetic moment of revolving electron around the nucleus of an atom. This is the magnetic moment. Where U means magnetic moment, E means charge, V means velocity of electron, V means radius of orbital. This two is constant. This is called the magnetic moment of revolving electron. Also, we find out this electron is revolving around the nucleus having some angular momentum. Therefore, let L be the angular momentum of electron. Therefore, L is equal to ME into PR, where ME is called mass of electron, where ME is called mass of electron. Using this equation, suppose we rearrange this equation in such a way that M is equal to EVR upon 2 into ME divided by M. Therefore, M is equal to E upon 2ME. We rearrange this equation, E upon 2ME into ME into PR. Therefore, this bracket is nothing but angular momentum. Therefore, M is equal to E upon 2ME into L into L, or M upon L is equal to E upon 2ME. M upon L is equal to E upon 2ME, where M means called magnetic moment, L means angular momentum, E means charge, ME means mass of electron, and that ratio, the ratio M upon L or E upon 2ME is called gyromagnetic ratio. It's called gyromagnetic ratio. The ratio M upon L or E upon 2ME, this is called gyromagnetic ratio. Also, suppose we used the Bohr's theory or Bohr's second postulate. Bohr second postulate. The electron revolving around the nucleus, then the angular momentum of electron is integral multiple of NH upon 2 pi. It's integral multiple of NH upon 2 pi. This is the Bohr's second postulate. Then we can written as L is equal to MPR, which is equal to NH upon 2 pi. Suppose this is equation second. L is equal to MVR is equal to NH upon 2 pi. Put these values of L in equation 2, we get M is equal to E upon 2ME into NH upon 2 pi. Or we get M is equal to ENH divided by 4 pi into M. This is called first Bohr orbit or first orbit's magnetic moment. If N is equal to 1 for first orbit or first orbit, therefore M is equal to N is equal to 1, hence EH divided by 4 pi M. Now this equation gives EH upon 4 pi ME. This quantity is called Bohr magneton. This quantity is called Bohr magneton. It's called Bohr magneton. Which quantity? M is equal to EH upon 4 pi into M, where M means magnetic dipole moment, E means charge on electron, H means Planck constant, 4 pi is constant, M is mass of electron, and this quantity M is equal to EH upon 4 pi Me is called Bohr magneton. This is about the magnetic moment of electron revolving around the nucleus. The answer of that topic is only up to relation I M is equal to EVR upon 2. Then next is our knowledge, what is meant by Bohr magneton, what is meant by gyromagnetic ratio, or what is meant by angular moment of electron.